Due to constant small mutations in the antigenic determinants of the surface proteins hemagglutinin HA and neuraminidase NA of an influenza virus, influenza vaccines are annually reformulated to recognize the most prevalent viral strains for that year's flu season. Influenza vaccines have been manufactured using an egg-based platform for decades, but inherent challenges warrant the development of alternative technologies. One such innovative technology is cell-based manufacturing. Cell-based technology offers several benefits over the traditional egg-based process. These include independence of egg supply, produces a truer match to the World Health Organization candidate vaccine virus, WHO CVV, and rapid scalability. WHO selected strains which have been isolated from clinical samples and termed candidate vaccine viruses, CVVs, are grown and processed via a proprietary cell line. Viruses which have the same antigenicity as the CVVs are propagated before harvest from the cell media. HA and NA proteins are purified to create a vaccine. The vaccine is administered via intramuscular injection. HA mismatch can occur in egg-derived vaccines, resulting from the WHO CVV undergoing reassortment to grow efficiently and robustly in the eggs. This can lead to the two processes generating different HA antibodies. The next few frames depict what might happen if this does occur. Upon exposure to the circulating influenza virus, memory B cells produced by the cell-derived vaccine are activated, similarly to memory B cells produced by the egg-derived vaccine, leading to the production of HA-specific antibodies. The antibodies then encounter the virus. The cell-derived antibodies can recognize and engage with viral HA proteins successfully, as the process provides a truer match to the WHO CVV. However, an HA mismatch generated during the egg manufacturing process means the egg-derived antibody might be less likely to recognize the viral protein as successfully. This difference in recognition can lead to lowered viral clearance by egg-derived antibodies following exposure, in contrast to cell-derived antibodies. Extensive quality control measures and genetic sequencing during the manufacturing process ensure that the cell-based influenza vaccine maintains high fidelity to the WHO-selected vaccine strains. Another benefit of cell-based manufacturing is the involvement of a continuous cell line grown in suspension that is suitable for rapid scale-up when needed, such as in the event of a pandemic, where a working cell CVV could potentially be created in a few days, around 4.5 days, with a viable vaccine available as early as 10 days. To summarize, cell-based technology offers several benefits over the traditional egg-based process, including independence of egg supply, produces a truer match to the WHO CVV, and rapid scalability.